I think what Frank did was really bring the search for life beyond the Earth into into modern science. He brought a modern scientific perspective to a very old question. He essentially sparked the search for extraterrestrial intelligence as we know it today. He laid the groundwork for everything that is happening now, and what is of course now a very vibrant field. He not only conducted the very first scientific search experimentally, he designed the instruments, he designed the observing program, he actually carried out the search. He also laid the theoretical framework for not just SETI, but really for all of astrobiology in the Drake equation. So responsible for both the experimental part, the observational part, as well as the theoretical part. And then he went on to found the SETI Institute, one of the most important programmatic structures within the search for extraterrestrial intelligence. So the Drake equation expresses n, the number of communicative civilizations that we might ultimately come into contact with, as the product of all of the factors that go into the emergence of that communicative civilization, the rate that stars form, the fraction of stars that have planets, and so on. And I think prior to that time, those actual kind of very important individual components, individual factors, had never been identified and really elucidated in that way. And I think Frank's development of that equation, I think, brought some credibility, some might even say certainty, to the possible emergence of intelligent life beyond Earth. I think up until that point, it was not clear that we would ever be able to make progress in any sort of quantitative way. It's really fascinating that when the Drake equation was first articulated, the only term that we really knew with any certainty was the rate that stars form. But over the last 60 years, since that equation was first articulated, we've seen a steady progression down the equation of being able to answer more and more of those factors with scientific certainty. We now know that essentially all of the stars in the Milky Way galaxy have a planetary system, largely thanks to Kepler. Also thanks to Kepler, we know that a fair fraction of stars has a planet that is Earth-like, at least in terms of its size and its temperature. Something like 1 in 5 or perhaps 1 in 6 stars has such a planet. And as we go on, you know, in the coming decade and in decades to come following, I think we will see more and more progression through that equation, and understanding more and more of it. And I think it really is a kind of a roadmap, if you will, that Frank articulated for us, and one that obviously is very exciting to follow, but I think conveys a huge amount of foresight and vision that Frank had in identifying each of these factors and motivating very concrete efforts to answer these questions that ultimately might allow us to answer the biggest question of all. I think there was always a feeling that perhaps there was something very unique about our own solar system. I think it's difficult to, in some ways, to not feel that way as human beings. It's nice to feel special, but what we've learned, really, again, just in the last 10 years or so, is that that's absolutely not the case. There's really nothing special about our circumstances here on Earth, and there's nothing special about our solar system, at least in many ways, relative to other solar systems. And I think that realization has really sharpened the question of whether or not there's life elsewhere in the universe. And I think is motivating a huge surge of activity in the field. And it's an incredibly exciting time. Now, just like people, I think, like to feel special about their place in the universe. I think scientists like to feel that they're perhaps doing their work in a very special time and a very exciting time. And so perhaps if you ask me this question on my 90th birthday, if I make it that far, I might have a different perspective on it. But it certainly is an amazing time to be looking for life beyond the Earth.